Right, and welcome to our first video for our permutations unit. We'll start off with fundamental counting principle. And this really plays off a lot like probability. So here we've got a scenario where we've got a bunch of clothes. We've got 3 different kinds of shirts, 2 different kinds of pants, and 2 shoes. How many outfits could we make? And like in probability, we want to maybe consider a sample space or the number of possible outcomes. So one way of doing this, people could make a list, you can use a table, but you could actually go through that process of, hey, event 1 is I'm going to put on a shirt. Which shirt am I going to put on? I could put on my blue one, my purple one, or my green one. After I put on a shirt, I better put on some pants. So if I had my blue shirt, I could either put on my black pants or my gray pants. With my purple shirt, I could get my black pants or my gray pants. And with my green shirt, I could wear my black pants or my green pants. And then finally, I could decide between the 2 options that I have for shoes. So I could wear runners or dress with my blue shirt, gray pants, and dress shoes. I'm just going to kind of complete this sample space so that we can kind of look to see how many different possible outcomes are there. Or in this case, how many different possible outfits. And each one is unique. Notice that the purple with the black pants and the running shoes only occurs once. So let's count them up. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So there's 12 different outfits that are possible. Now, fundamental counting principle is another way of doing this because this is fine for only 12 possible outfits, but there could be a whole lot more. So what we want to do is we want to say, how many shirts do we have? How many pants do we have? And how many shoes possible? So when I pick a shirt, I have 3 shirts to choose from. When I pick pants, there's 2 pants that I can pick from. And there's 2 kinds of shoes. And if we multiply those guys together, we also get 12. So this idea of sort of multiplying through to get, the total possibilities, unique possibilities, that's called our fundamental counting principle. So here, let's just take a look at one question here. We've got 5 colors of markers, and I'm trying to arrange them, put them in order. How many different ways, unique ways, could I arrange them? So what I'd like to suggest is that we these are placeholders. These are not meant to look like divide. It's just like a blank, so this would be like the first marker. This is the second marker, etc., etc. So right now for the first marker, I have 5 to choose from. So there's 5 different things that could be in the first spot. So I'm going to pick this one. That's my first marker now. Now, for my second marker, I only have 4 left to pick from. So any of those 4, I'm going to pick this one. Great. Now, for the third marker, there's 3 choices left. For the fourth marker, there's only 2 choices left. And then once I put this down, there's no choice. There's only one possibility. So now when I multiply those guys through, I see that there's 120 different arrangements for the markers. So there was 120 unique ways for me to have arranged these 5 markers. So we could be doing this kind of thing with objects. We could be doing it. A common one is letters in a word. So here we're trying to rearrange all the letters in the word chemistry. 1, 2, 3, 4, 5, 6, 7, 8, 9 letters altogether. And so and basically once you use one, then you can't use them again. So we would have 9 letters to pick for the first one. And let's say if I picked an M. Okay, great. An M's gone. Now I've got 8 letters left to pick from. I'm going to pick a T. Now I've got 7 letters left to pick from. So you can see how this is going to, go all the way down to 1. Now this here, what we're seeing, is actually called a factorial. And we use this exclamation mark because we're showing that it's going from 9 down to 1, and it's multiplied by every integer in between. So it's all the integers from 9 to 1, and they're all multiplied to each other. And this exclamation mark is also a button on your calculator. So you might have this as the button, or you might have this as the button. But yeah, take a look. You'll see an exclamation mark there. But the factorial only applies to something that goes down by every single integer down all the way to 1. So we could do part of it, where we're arranging part of a group as well. So here we have 20 students, but they're competing. They're not competing for 20 different things. So we're not arranging all 20 students. We only have 5 scholarships. So every student can only win once. So here's the first scholarship, second, third, fourth, and fifth scholarship. So how many students could possibly win the first? Well, all 20. And then after one student has already won, they can't win again. So there'll be 19 left for the second one. And all the way down. Now this number is absolutely enormous. Where is it? Let's get that number back. So there's almost 2 million different ways that 20 students could win each of the 5 scholarships. But it's possible that the students could, like in another scenario, every student could win more than once, which means that a student could win like maybe all 5, like one student could win all 5. So if we're trying to represent that part of the group, the first student, there's 20 students that could win the first scholarship. And when we go to the second scholarship, there's still 20 students because they could repeat. And then for the third scholarship, there's still 20. So there's really like 3.2 million different ways that 20 students could compete for 5 scholarships if they could all win all of them. Whew. So with the first scenario, we had a part of a group. We were showing a part of the group. There was 20 students. They're placed over 5 positions or 5 scholarships. So this is called permutation notation, and we can kind of represent it like this. So we have 20 students in the group. There's 5 scholarships that can win, and we have to be going down 1 every time. So for example, if we did have a permutation notation, you could write this one out. So we've got 3 spots, 1, 2, 3, and there's 15 items to fill. And once the item gets used, we're going to have 1 less. Like that. So again, this is also another button that's on your calculator, and it should look like this. Another example of using the word chemistry, but now we're not going to rearrange all of the letters. We're only going to we're only going to create 4-letter words. They're not even words, they're just arrangements because it's probably nonsense. So just to remind ourselves, there was 9 letters altogether in chemistry, so any one of the first ones could be used. Once we use a letter, then there's only 8 letters remaining. And if we wanted to show this as permutation notation, we would start with a big P. We would say I had 9 items and I arranged them over 4 positions. And so the last thing that I want to look at is simplifying. This is just sort of playing around because, as you can tell, these numbers get really big. So sometimes when we have factorials, we like to expand them and then sort of cancel them out. So I'm going to kind of expand this here. So with the 5 factorial on the bottom, the 5 factorial, if we expand or pull that out, 5 times 4, we want to take it all the way down to 1. The 6 factorial, and then, 56 is kind of weird out front. Like, what is that even doing there? But 56 is actually a little bit sneaky because it's sort of like 8 times 7. So really, this is even like the 8 factorial out front, which is kind of cool. And so what we want to do is cancel out like terms. So here we could see this 5 factorial and this 5 factorial. We're going to cancel those. And so all that we'll have is 8 times 7 times 6. So 336, which is a whole lot better than trying to like multiply all those guys and then multiply again and then divide. So it's a lot nicer to be able to sort of cancel them out. So in terms of like the credit assignments or the hand-ins, although you can multiply, we're really supposed to be expanding and canceling. So please do show those in your steps. Thank you.